Okay, so polynomial functions, graphing them, day 3. In this video, we're going to work in reverse. You are going to be given the function in completely factored form, and you are going to identify characteristics like the degree, the starting, the ending behavior, what the zeros are, what their multiplicity is, and then finally, we wrap it up by you are going to graph polynomial functions in factored form. So let's get started and see how we do. Okay, so example 8 in my notes. I ask you to do these 4 things for each one of these. So I'm going to kind of do the first one, maybe first 2 with you, and then I want you to pause the video and try the third one on your own. So think, step 1. I want you to identify what is the degree of that function. Remember, the degree is your highest number of it. It's your highest exponent. So if I count, I have 2 zeros there. I have 1 0 there. I know absolutely that my degree is 3. Part 2 says to state the zeros and their multiplicity. So think, if x plus 2 is the factor, what is its 0? X minus 3 is the factor, what is its 0? Well, -2 and +3. Notice that -2 has a multiplicity of 2, aka it's a double root. What happens at double roots? Think about that, because you know you're going to have to eventually graph these. What happens at double roots? Part 3, describe the end behavior. So the end behavior, think about what this thing does on the right. I know end behavior is all about the leading coefficient. Well, the leading coefficient is positive in this one. So I know that my end behavior, this thing is going to end up. Okay, think about if it ends up, what are we thinking? If it ends this way, I know that what's happening is x is approaching infinity, y is approaching infinity as well. That's why the interval notation, or I'm sorry, the limit notation looks like that. And then number 4 says to find the y-intercept. Uh-oh. Bad news. I can't see the y-intercept the way that I'm looking at this right now. So in order, if it's completely factored, probably should write this down. To find the y-intercept in completely factored form, what I'm going to do is simply plug in a 0 wherever I see an x. Every single time in completely factored form, in order to find the y-intercept, you just plug in 0 for x. So think, if I plug in 0 here, 0 plus 2 is 2. 2 squared is 4. If I plug in 0 here, 0 minus 3 is -3. 4 times -3 is how I got that 0, comma, -12. Notice I said x had to be 0. Therefore, the y is -12. Okay? Letter B. What's the degree of that? Well, you should be saying it's 4th degree. I know this is a triple root. I know this is a single root. So I know I have 4 of them. What are your zeros? -5, which has a multiplicity of 3, and +2, which you could put has a multiplicity of 1, but not necessary. End behavior. Notice the end behavior. This thing finishes down. That negative tells me that this thing finishes down. So if you need to draw your graph that it finishes like this, to understand that x is approaching positive infinity, y is approaching negative infinity, right? That's how I'm getting those right there. And last one, y-intercept, again, plug in 0. Wherever you see an x, plug in 0 there, plug in 0 there. 0 plus 5 is 5. 5 cubed is 125. 0 minus 2 is negative 2. 125 times negative 2 is actually 250, not 150. Negative 250. And then if I do that, I don't know why I wrote positive 150 when it should actually be positive 250. Okay. Last one, letter C. Why don't you give it a shot? Try that on your own. Pause your video here, see what you can do. Okay, so first thing I notice is that it's not completely factored, right? So you have to completely factor that. Hopefully you ran into that. Hopefully you picked up on that. If not, take a look at what I did. I took the x squared plus 1 and I set it equal to 0. So I got x squared equals negative 1, and when I take the square root of negative 1, it's plus or minus I. So there is how I got that, plus I and minus I. Okay, so hopefully that's okay for you. From here, now I can find my zeros. My degree is obviously 5. My zeros, there they are. I know it ends down because of that negative out front. And I know my y-intercept is 0, 27. How did I get 0, 27? What I decided to do was just plug in 0 into my original function. I would always do that. Plug in 0 into the original, not into the factored form. Alright, so here it is, where we end up. I'm going to ask you to sketch. Notice keyword sketch, right? Doesn't have to be exact. Let's sketch them. Sketch what each of the graphs of these polynomial functions look like. So, kind of give you kind of rundown of what I do. First thing, I always identify the zeros. Okay, for the x, that's 0. For the x plus 2, that's negative 2. So I identify the zeros and whether they're double, triple, single, whatever roots they are. Next, I always decide, after I plot my zeros, I know the degree is 3. I figure out what this thing does on the right. So I know my leading coefficient tells me what it does on the right. So my leading coefficient, you kind of get the point, it's not pointing to it right now. My leading coefficient is positive, that it tells me that it ends up. Because it's a degree 3, I know it has opposite behavior. Okay, so always the order in which I do things. So, now I'm ready to graph this. I know at negative 2 it should be a double root, so what should happen is it should hit and bounce off of it. At positive 0 it's a single root, so notice that my graphs, the ends and the starts, they match. They should always obviously match. Okay, letter B. Do this maybe 2 more times for you, and then I'm going to zip through. Okay, your degree is obviously 3. There are my roots. I plot them. My ending behavior is obviously down because of that negative right there. I know it starts up because degree is 3, it has opposite behavior. So at negative 1 it's a double root, it should hit and bounce. At positive 3 it should go right through it, and voila, there it is. Okay, 2 more. C and D. I'm going to go a little bit faster. The degree. Your zeros, which are both triple roots. Okay, so if I plot them, start and end in the same direction. Remember, at triple roots, they should flatten out, then go through. Flatten out, then go through. And last one, letter D. Degree is obviously 4. Looks like we got 2 double roots there. Start and end in the same direction, which should be down. Double roots, they should both bounce. Okay, so identifying characteristics when it's in completely factored form, got it. Graphing them, got it. Okay, so hopefully you got graphing down. And we have now completely put everything together from start to finish, your P's and Q's, your synthetic division, factoring whatever you have left. Once it's in completely factored form, voila, now we know how to draw the sketch of them, and we are done. Good job.